So my name is Gregory Estrade. I'm also now like Taurus on Twitter, GitHub, and some forum as well. I work for a company called Lyra Network, which is a payment service provider. I have the role of development director. I have about 50 engineers working on a payment platform under my responsibility. But I'm also quite technical guy because I like to do some hardware hacking as well, and embedded development. My talk tonight is about security concern for the internet, as we already know it. But also it will be extended to some point to the IoT, because the problem with the IoT is that you will get more and more devices, low power devices with a limited amount of hardware and software capabilities connected to the internet, and above all, these devices will be close to our body, I mean wearables, so they will be able to disclose more and more information about ourselves. Okay. So the popular IoT application, as we already mentioned them in the previous talk, are home automation, smart cities, wearable healthcare, and so. And these applications often use a set of protocols that have been either designed or reused for the IoT. I mean, for instance, protocols like XMPP or MQTT are protocols that take their root in 1999. And at the networking level, we have newer protocols like SexLoWPAN, RPL for routing, and DTLS for datagram TLS for bringing a TLS equivalent to datagram-based devices. Oh, sorry. So the focus of this talk will be home automation using MQTT. For those who may not be aware of what is MQTT, it's a very simple protocol which has an interesting model for all sensors-based automation, because it's a publisher-subscriber model. One of the requirements for MQTT is the use of a broker that is responsible for message passing. At its roots, MQTT was TCP-based protocol, and it has been somewhat extended to MQTT SN specification, SN standing for Sensor Network, and it allows the use of non-TCP transport layer like ZigBee or serial links and kind of stuff. So let's build a simple home automation system. We get sensors. In MQTT, the MQTT resources looks much like HTTP or REST. It's more or less based on URLs with a different with a few chains, but let's consider those are URL for now. For instance, we could have sensors for temperature and humidity are the other side. Commands to get to open your garage door or to tune up your radiator to a level you want for warming up or cooling down a room. And for all these sensors and commands, you have different requirements. For instance, in your house, the outside humidity could be shared with your neighbors that wouldn't want to add a sensor for it, or be broadcasted to weather forecast services that could collect your data to build better models of for weather forecast, for instance. Some data may be shared only to a set of people. For instance, if you're going on holidays, you may want that your neighbor were able to get the status of your garage door. If you're not supposed to be there, then your garage door is not supposed to be open. But disclosing the status of your garage door to everyone on the internet wouldn't be a good idea. Some commands need to be just protected. If you change the level of a radiator, well, it shouldn't have a very difficult, very painful consequences. However, some commands need to be secure. A garage door, if you want to replace your radio or infrared based system with your smartphone, well, it's fine. But the downside of this is that you might open your garage door when you are 100 kilometers away, which surely isn't what you would want. Or maybe just to allow someone that could have lost his keys, for example, for example, your son or daughter coming back from school, forgetting his keys and this kind of stuff. But for this purpose, we need a two-factor authentication at least, because you have to ensure more security, as misuse of this feature would leave your house open to anyone. Okay, so let's build our system. It's quite easy. MQTT is really easy to set up, and you imagine you're performing your local installation, everything works fine, and then you connect it to the internet or the IoT. For finding your home, you would like maybe a domain name, a DNS location, a Greg's house, for instance. And for security, you will choose a good old security standard, like not SSL anymore, of course, but TLS. And you will handle this for security, maybe with client certificates and only server certificates, this kind of stuff. But you would also make these certificates public and registered, so that people that would like to get your data, even if it's freely available, make sure that this data really comes from you. But okay, so I guess we're done. Not really. Let's talk about the two roots of our main concerns currently with security, privacy, especially privacy. For these the latest years or 2 years, I mean, there have been a very well spread in the news. DNS is a protocol that is weak. I think the first domain name takes its root in I think it was Xerox in 1995. So, no, 1985. Yes, that's 30 years from now, which is a lot in a internet world. Then there have been abuse. I don't know if anyone here remember the dicky move of VeriSign in 2003. They broke the whole internet with this abuse. And then there's a protocol weakness. It's the UDP protocol. There is no all the messages are sent in a plain text or plain data. It's really easy to spoof, to do some cache poisoning, to prevent some DNS server to deliver an answer. Well, I know you're aware of security, so these things are known to you. Sorry. With SSL and TLS, there have been implementation issues, especially for OpenSSL, Heartbleed, Poodle, and you surely have heard that a new set of vulnerabilities will be disclosed on Monday the 19th of March. So I think Monday won't be a good day for sysadmins over the world. Then still this case of abuse. There's the infamous self-signed certificate added by Lenovo to their laptops, just to put ads on Google page, and that breaks all DNS security. TLS security as it is intended to be used. And then more difficult to grasp issue related to cryptography. There have been the Debian random name generation issue that made private key issue generating Debian boxes very easy to crack. And then all of those are links. I encourage you to read the RSA key backdoor, which is a very interesting article. The principle is that you get your private key for information on the private key on the public key, making the key easy to crack. Well, DNS and SSL have had their implementation issues, are some protocol weakness, but that's not the main point. The main point is the way they are used. They are used, all our internet as we know it use a hierarchical class model, which is which had its interest at the early beginning of the internet, but with all the recent events in the news, this is clearly not the way to go anymore. So let's talk about blockchains. Blockchains term blockchain comes from the Bitcoin paper. It's basically a set of transactions. It's a ledger So you keep the balance of ownership of if Bitcoin or the system in a secure way, and the blockchain is not made available from download or from a particular website. It is shared by the network of a blockchain client. Question is, why does it work? Adding blocks to the chain means solving a computational hungry problem. It's not you cannot solve this mathematical problem with a brute force. It's much more like a lottery. So as for a lottery, you don't have more chance to find a solution to the problem than your neighbor. So why would people add blocks to the blockchain and verify transactions proceeded by others? That's because there is a reward. The reward is simply, in the case of cryptocurrencies, it's money. And everyone is a bit greedy. Everyone, I think, would like to have free money. And by using this incentive, this motivation that is shared by everyone running a Bitcoin client, then most people that are honest people sharing just this little defect called greed, we would outperform in terms of computational power. There's few people that would try to hijack the network. So it's not something that is easy to hear, but if you trust someone, you end up being disappointed, because the history of abuse on internet, on the backbone of internet, especially this last month, show that you cannot trust anyone anymore. For greed, it's very different, because everyone shares the same greed, more or less. So some people are more greedy than others, but most people are greedy. We are all. Okay, why not? Okay, I can build a blockchain. I know that it will be kept consistent by the network, but so who cares? Interestingly, major player of computing in general and in the IoT I've sensed that this idea of decentralized way of securing things is not a bad idea. So the set of technology used, Ethereum is basically a blockchain, TDH is a distributed hash table, and BitTorrent is used for file transfer. And funny thing is that 8 months ago, I had the same idea, and I created this simple protocol, proof of concept, sorry, Mosquito Twister. What is it? Twitter is like a decentralized Twitter, sorry, that has been designed by a Colombian information technology researcher. A blockchain is used for storing handles, so you cannot have your account removed on this kind of stuff. There is no central authority that would do censorship of handles or what are published under this handle. User profiles are stored in a distributed hash table. The best known distributed hash table network was Academia, used by BitTorrent to make a fully decentralized trackers. The trackers were the weak point of BitTorrent at the beginning. And then all the data, so posts, are distributed like in BitTorrent swarms. A swarm is a set of users that share the same data of in BitTorrent case files. In a Twitter case, only post. Direct messages are encrypted. Other messages are not, for obvious reasons. So, what does it have to do with MQTT? Well, you need to know and show that your house is your own house. If you trust on a third-party provider for DNS, with all concerns that that's been addressed, one, you disclose too much security, too much information. You are disclosing, for instance, your IP address, which is unnecessary in this case. And why did I choose to use Twitter for this purpose? Just because the publish-subscribe model fits exactly the Twitter model. People can subscribe, follow you on Twitter, they get the public information that you want to disclose, and then with a matter of followers and followers and following, you can ensure security. For instance, if you decide to trust someone, your neighbor, with that has proven its identity beforehand on offline, let's say, on checking process. On checking, I mean, can be really shake hands with your neighbor and say, okay, let's see what I've done in my house. I'm trusting you to watch it while I'm on holiday, for instance. Okay. Now, as I've seen that question and answer section was a bit calm, I decided to add some ideas for you to think about security in general. We have talked many times about the difficulty to store private keys, but there are ways to avoid the storage of a whole key into a single device. One other topic could be adaptive security. Adaptive security is it's UX part of the security. You have to choose wisely what level of security you choose to one given situation. For €5 train ticket, NFC card will do. For larger amounts, you might want to add more to increase the security. Increasing security is not by increasing the security. I do not mean increase the security of a given device, but to combine many devices, and it is related to the former point. Use a quorum. So decide that for this operation, if I want to withdraw €100 from a cash machine, then I will maybe ask for two pieces of authentication that would be stored across multiple objects, that in a secret sharing way. And to that point, cryptography, it's quite obviously stated that a strong cryptography as a root of IT security. However, working with banks, with traditional electronic fund transfer system, as you may work with from time to time, especially people that are in the PCI stuff. You may wonder why when we're talking about 2048 bits keys for securing your Facebook post and your picture of your cat or whatever. Why do you accept to secure an object, a credit card, with a 4-digit PIN code, and which use cryptography, which is a triple dash, but with only 2 keys, which represent a grand total of 112 bit key to secure your whole bank account. And you must admit that it works. It's not perfect, but it works. So, and then for those that are more familiar with the blockchain and cryptocurrencies, that's an open topic and no answer. It's just because I want to share my own thoughts and feelings about this part. First part would be the creation of a distributed blockchain storage, because the blockchain Bitcoin blockchain, is about gigabytes. For other cryptocurrencies, it can end up to terabytes of data, which makes it inefficient and inappropriate for running devices of the IoT. And then back to my idea of trust and greed, especially greed. For such a blockchain system to work, you have to ensure that the incentive is powerful, is motivating. There are technical solutions to address the issue with DNS and HTTPS as well. That's the DNS chain project, but you may wonder what could be the incentive of such a project to make people willing to participate and free them from the power of people that and companies that we used to trust and that have betrayed us countless times. And I think with the IoT, it's like building a new internet, and we need to take this opportunity to make it to bring back internet to the people and not the corporation and the government. Thank you.